Testing, testing, 1, 2. Yeah, I think that's okay. Okay, so I'm still on the paths. No surprise there. I have a strange situation where it says on the top left path full, which means it found a good path. But if I look at what it found, I can't do that right here. 1 sec, I have to change this. I can show the path. So blue is no path, pink is path. So here's a path, here's a path, but they should of course be connected at the very least. And I'm not sure if there's other dangling stuff. Not this time, but there could be more of them just hanging around randomly. In the top right, there's a path variable display. It says path 0. That means index 0. This patch is the index 0 of the path. And this one, oops, this one is index 2. So index 1 is missing. If I look at these non-marked paths, patches, there's no path mark, so they're not in the path. It only says patch for them, PCH. And other stuff if I move over entities, but or objects, that is, not entities. And yeah, so this is super weird. I checked the display code, which is always good to do when you're visualizing stuff. Check the display code, it should be fine. It's really simple. And yeah, if I look at this patch, path index 0, let me hide the objects. So there are these boundaries here, which it should take, of course. To find the next patch segment. For example, this one or this one, but that's not in the path. Or this one, but that's not in the path either. So it only has these 3 options. It can either go this way, from here, or this way. if this really is path 0. I mean, it can be, there's a goal here. That's a prerequisite to it being path number 0. But it, I mean, chooses to go over here somehow. But this is also not path index 1, the next one, but 2. So it skipped 1. It might be, maybe there's a single tile that's path number 1. Would probably be around there. Around the boundaries. The red tiles, these ones. That's also path 0. Wait, why is this path 0? That's weird. Okay, this is clean. Also no path here. I mean, it would be painted pink. Yeah, so this is, as you can see here, I get PCH patch 356. If I move into the boundary, I get FMP -2, which means flood map value -2, which means it's probably unflooded. Yeah, that makes sense because the patch detection code stops at these boundaries. So this is not registered, which is fine. But okay, let's think this through. Each boundary has 2 neighbors, should have 2 neighbors. There might be 3 in some cases. But this is obviously 1 and this is number 2 for this boundary. I detect the neighbors by going through them and checking the neighbors. Oh, okay. There might be a problem already. So for this tile, it checks the neighbors, which is up. It sees, okay, patch number 356 lives here. That's my neighbor. It sets this as the first neighbor. Then it looks here, nothing there. It looks here, nothing there. It looks here. And it sees the same patch again. I'm not sure if I handle that. Here it is. It looks around the 4 cardinal directions. It does an elevation check. Oh, that's also bad. that was a bug right there. But the other thing still stands. So if the boundary in its first slot already has the patch, or in its second slot has the patch, then don't save it. Otherwise, if the first one is not set, then put it there. Else, if the second one is set, put it there. Okay, path is still full. So path 0 is now here. And I have other stuff over here. Path 60. Path 9. So it's still confused. I think I'm mixing up indices with something else. That's the only way I can explain this. Anything else? This one as well. 5. Let's look at the boundaries. There's only one. So it has to go there. Yeah, let me add another visualization. And that is if there's a boundary here, so this, yeah, I'll have to move this. Actually, I don't have to do anything. I have to, so let's put it here. Struct bound add. And these are only in layer 2. So for this, if the, well, do I actually save the position? Yeah. If the position is the same between this bound and the passed in position, return it, else return null. No prototype and a class static. Okay, that's what I wanted. Let's export this and use it up here. And what we'll do is we'll print path. We'll print the index of the boundary is irrelevant, but the patches it leads to are not. So B patches 0, 1. Incomplete type. Okay, that makes sense. So this needs to go into the structs. Okay. So now I can theoretically hover over this, but I can't. Oh, that's because the position is only in one tile. Let me check that. Well, not even that. Should get a hit on at least one tile. Maybe that's the problem. Do I set the position? Pretty sure I do. Find boundaries. Yeah. Okay, let's look at the display code. Here. I mean, that looks good to me. Oh, there they are. Okay, it's just some compilation stuff. Oh, but these are different. So there is a bug here. So down here I have patch 210. Here this is 125. And these are all individual boundaries. Are they? But these down here only point to this patch. And these up here only point to this one. So of course this is screwed up. Oh, actually here is the correct one. Pointing to both of them. But why are these in there as well? So that was a good call to add this thing. Because I think I'm not that far away from having this work. It's just bad programming. So let's look at how the bounds are found here. So I have a flood map. I go through the world. If I have too many bounds already found, I skip. And if there's not a tile at this position in the world, then I skip as well. And if the tile is not marked a boundary, I skip as well. And then if this is marked in the flood map, then I skip as well. Then I pick the next bound, I add the position, and then I flood it. So there's something missing here. That causes it to go over the others still. So this is the flood function. I flood the bounds, the red tiles. I do the same skips as here. And all I'm doing is I'm collecting the patches. Which is this. But I'm not adding. So why is this not skipping? So after the flooding, y times world width plus x. I set the flood map value. So if this returns and it's taking the tile 1 to the left or right, it should skip it right here because it's been flooded. Maybe I should set this here. Doesn't matter. Does it here. Oh, this should be this. Should of course check where it's currently moving. This one looks fine. Okay, let's try this. I mean, we've got more this time, but path 0, path 2, four, 9, 3, still nonsensical. But more, it makes more sense now. But this doesn't. It's path 30. Don't get it. Oh, actually... No, yeah. Just doesn't make sense. I was looking if it maybe there were dead path segments from previous runs, but doesn't seem so. Anyways, I should check the boundaries now. Okay, now they're dead again. Well, there's a boundary here. But it's what's going on? So this is 288. This is 318. So this single tile here is correct. This one's false, etc. And there are still so many of them. Okay, we still haven't solved that problem. Find boundaries here. I think I'll have to, this might be a chicken and the egg problem. I think I have to put these tiles into an array as I did in the old pathfinding, which is bad, but so this should return a list of tiles. Um, Okay, it didn't like that. Did not like that. Looks like a Stack Overflow. That's, yeah, I mean, okay, let's see what it did this time. That looks better. It looked better for a really short while. So this is patch 0. Path 0, I mean. Where's number 2? Here's number 2. And then we go straight into 12. And how did it get up? How did it get up here? Because that's not allowed. From down here to up here. There's no direct path. So what did it do? It took this exit, which points up, which is of course nonsensical. And I think I explicitly disallowed that. But it seems I didn't here. So let's take the elevation check. Can actually just plop that in. Let's try again. Okay. It looks like it's tunneling. What is it doing down here? What have I done? 12, 11, 10, 35, 5. Am I... Am I confusing the layers? Oh, okay. Patch L should be 2. Okay, so that's much better. So I did make it confuse the layers. Path 20, path 2, path 0, okay, 18. How did it get to... How did it get up here to path... Oh, actually, I need path 1. Where's path 1? I have 18 here, but... Path 1, path 1... Yeah, so these are fixed as well, it looks like. Yeah, the boundary is only in the top left corner. Well, it used to be. It's not on this one. But maybe it's just not displayed. But I don't think so. No, should be displayed. So this should maybe be a real flood map with indices. So let me think. The patch gathers all the boundaries around it. And how does it do that? So that's finding all the boundaries in the world, but this is what I want. Okay, it iterates through all bounds and looks if itself is marked as a neighbor in them. That's okay. So this is still weird. For 1, 4, 1, 2, 1. Okay, that makes sense. And this is just wrong. It's taking this boundary says it leads up here. It is wrong, of course. I think I added the elevation check, but apparently that's not enough. Oh, that's, yeah. That's a typo as well. Okay, let's look at this. 288, and the right of this should be 318, and it is. Okay, this is more interesting. 352. Well, this counts as its own patch. Well, that's the question. So yeah, this single tile counts as its own patch, which is bad because this boundary says it's this tile that leads to this patch. So I need, when I create the patches, I need to clamp them to multiples of 2. Where's the height check? Can flood. Okay, let's just make this greater than 1. This should take care of it. Yeah. Same situation here. Okay, it's still a different patch. But that is it actually. Okay, that's all tessellation stuff. But I want the patch definitions. Okay, we're in the proc stuff. And we're back. Oh, I have the portal. Rules. Should maybe change this. Wow, this is didn't think this would leak into the patch detection stuff. Tile return, no flag. Okay. Maybe the boundaries are behaving now. Okay, this is not a patch now, so that's, I mean, it's different at least. But this is okay, I can still walk there. $182, $190, so this is correct. Let's look at something more difficult like this. Okay, 171, it's not connected at all, of course. I think this should just go. Or I should make this a bridge. While I'm here, let's do it. And remove these. And then I can add this, which is of course not registered yet. So 161 and 171. 161 is up here, 171 is down here. This is not a patch. So 171 was here. This says 146 is on the other side, which it is. 146, 176, that's correct as well. So that's making me hopeful. 174, and this is unregistered. 143, it says. What is 143? I'm just not, just can't read. Okay. So let's see what the path is doing. I mean, it's doing something. There's a gap here. which is of course not that great. And it still seems scrambled. 88, 87, 30, 33, 26. I mean, I can go through these. There's no path set. I mean, this is painted, but not sure what's going on there. There's more down here. Okay, so this is index 2, 5, 6, 7, 10. So they are kind of adjacent. So this is 0. And 0 chose to go down here. And path 2 is a bit awkward. Should maybe cut this somewhere. So where's number 3? This is 5. So did it skip 3 and 4? And it goes and it went straight to 5. Or I'm missing something. I don't think so. Yeah, this is just weird painting stuff. Oh, it's exactly the same pattern, just painted on the other layers. Okay. Where's path 3? I mean, 5 is here. So it has to go there. So it's going there immediately, but skipping numbers. So here's 6. Then comes 7. There's 10. So there's no 8. Where's the 8? Okay, 10. 11, 12, 23. Skipping 11 patches. Path segments. Why would it do that? Then we're at 23 and it goes to nowhere. Um, okay, 44, 29, 31. Wait, are these just... Is this just a problem of them not being marked with a region? That could be the problem. So I could just give them all a region, but this shouldn't happen. There should be some default in place. The problem is I don't even know what the problem is. I think it's in find patch. Hello. Patch add. Yeah. So here I reject the patch, but only if it's not connected and it doesn't have a region. Empty is -2. What is empty? When I cleared it. And I only do that if I reject it. So let's see. Where I rejected that. I mean, clearly. I mean, I can. So the boundaries are empty. As is this. But why is this empty? Why is this not given a patch? Let's look at other. Yeah, this is. Okay. Should be connected now and colored in. Still not. What's going on? Because it doesn't have a region. But that's exactly what I checked. Where am I? Here. No, here. Yeah, no, I'm stupid. I'm looking at the wrong thing. I need this. But yeah, checking with the empty and unfilled flags was correct actually. No, but not the looking at the colors. So now it's I should look at the colors. So everything gray is not flooded. I mean, it was flooded but rejected. So why is this rejected? It clearly has connections. This one as well as this one. Where is this? It's just down from there. Let's place a marker. Let's see what happens. all the way over here. Okay, and then it's colored in. So it's not counted as connected. Because otherwise I wouldn't need the region marker. Let's remove them again. And let's look at the clear, what was it? Flood something. CL flood. So here, it's not connected and does not have a region. Clear the patch. But it clearly has a connection because it's... Oh yeah, I'm not flooding them. I'm not returning them. Stop at a ladder. That's obsolete. Cardinal directions can flood. So I want the boundaries to be included. Return 0. I mean, I wanted to stop there, but so the question is, why do I need the patches to be marked as connected, not connected? And that is all in patch add. Come on. So patch add, the position in the world returns 0 if it's outside of the play area, and I test that with this connected not connected thing. And the question is, where in these calls is there a out of bounds question. I think I'll have to look at it myself. Patch add. That has nothing to do with out of bounds. Render info, also nothing. Render map. That has to do with out of bounds. But I'm not sure if I need the map. Anymore. Actually, I don't think so. Actually, I can solve this with checking if the... Well, actually, can I? If the patch is in the path. So that's solved in patch add. Prevent stepping off path. That's worse. Okay, it might be easier to fix the other stuff. So let's look at the let's look at this. Can flood. It should stop, but it should also register. that it hit a boundary. Yeah, that's how I do it. So what is return 1? Flood patch. It doesn't matter. Okay. Then remove this. So this comes in, it saves the tile in the return array, but it then stops flooding if it's a boundary tile. And that should do it, I think. And then I come in here and I see this, and then it's connected. Put me back here. And it's still gray. Okay, it flooded these two, so that's good. These are also flooded. If I look at the info in the top right, this is flooded from the other side, so the one right to this one should be -2 in the flood map. Yeah. Then the next one is flooded as well. Okay, so this is actually working. But the check is not working. This. If kind. Okay, I mean, that's completely stupid. That's maybe why. And that looks much better, but this looks bad. What is this? Okay, so maybe I shouldn't flood it. Two, 6, 5, and what? And this. Yeah, that's bad. Actually, I should check the tile here. See if it's a boundary and not flood. Well, that's going to cost me a bit more time processing, but on the other hand, I skip all the tiles. If tile flag has bound, continue. Declared. Okay. Oh, this looks pretty good. This looks pretty good. But why is this the same patch? Oh. I know why. Okay. The elevation check. It can flood. It can flood, but only if it's going downward. If the height is less than 1 or the height is greater than the 0, return. Overlapping. What's overlapping? Oh, yeah, one sign missing. Okay, so this is better, maybe. See the same location. Yeah, so these stairs now belong to the upper patch. Oh, it looks so much better. Okay, this one is still not flooded. Why? Clearly. That's just a normal. Maybe because it's a. Well, actually, I don't know. What is this? That's wrong. Okay, I read that wrong. This is its own patch. Yeah, this one is pretty bad as well. Need to remove all the ledges that are between patches. But I think I can try again with the pathfinding. Maybe this time it'll work better. I really just need to turn on the visualization. Okay, still holds, but it looks a bit better still. Let's see. Yeah, this is, I mean, this is makes no sense. Actually makes no sense. So where's this 0? 16, 37. Oh, there's more here. What? Okay, makes sense. If it doesn't care where it goes, certainly doesn't care about the world boundaries. Okay, we're getting closer. 4, 2, 0. Okay, let's look at this. So that's correct. It goes up here. Then I'm at 2 instead of 1. Okay, then I'm... Okay, this is 3. Wait, did I just... Is there 1 in here somewhere? I don't see it. No, all path 2. Okay, it doesn't go over here. But it could. It didn't. So that's kind of good. 3. Going down to 4. Okay, then we're at 7. Here's the 4. Down here is 10, but it goes to 7, I think. No, this is 8. 7, 8. Well, how does it get out of here? Well, it doesn't. It dies. But somehow it decided to go up here, maybe. That would explain the 2. But not the 3. Don't get it. Don't get it. Need more info. Would really like to finish this today, but that might not happen. So let's look at the path code again. Generate the path. Find the goal points. Find all boundaries. And then find the path. Find the goal points. Everything happens in layer 2. Reset the count. Go over all tiles in the world. If the goal point is full, then break. Otherwise, if you find a tile and that tile has a goal object on it, then save that. Easy enough. Then we have find the boundaries. Same thing here. Create a flood map just for this function call. Reset the count for all tiles in the world. If the boundaries are full, then break. If there's a tile at the position, if there's no tile, continue. If there's not a boundary here, continue. If we've been here before, continue. Otherwise, pick a new boundary of the list and initialize it. And then begin a flood fill at that position, at the boundary flagged tile. With the flood map, with a pointer to the boundary and the position. So we come in here, we mark the tile as seen, and then we collect the patches around the boundary. And we do that by looking at the cardinal directions, looking if the tile there exists and is not a boundary, and if it's at the same elevation level, so it's not on a hill or in a hole, then we find the patch at that position and if the boundary has the patch already saved in one of its 2 slots, has the patch saved as in one of its slots, then skip it. Otherwise, save the patch in the slot that's not occupied already. So now we have a boundary with 2 patches, hopefully. Actually, I just remembered something. I thought there was something with the patch indices. How are they set? They are set here. That might not be correct. Actually, is that true? They should be correct. Get a patch of this of the list. And set its index to where it was taken off. Oh yeah, it was with this clearing. I think that's fixed. It's to do with the flood map, and if that is correct. So the flood map holds the flood map holds the indices of the patches as well. So I remember vaguely that there was an issue there, but I don't think there is anymore. And I can actually easily check that. Then assert like this. Okay. So where were we? We have the bound, one bound with the patches it leads to, two of them. And then, yeah, we found the bound tile while iterating all tiles in the world. Started flooding here for the boundary. We marked the tile as visited. We collected the patches at this point. Because this function is recursive, this will be called for every flooded boundary tile nearby. So we look at the neighbors. If there's at each neighbor, if there's a tile there, and if there's a boundary there, and if the elevation is correct, and it's not flooded, I'll move this up because it's cheaper. If it's not visited, then flood it again. Flood the next tile, which we'll call this again. So that gives me for this boundary, it marks all the tiles as visited. And it gives me the patches that this boundary connects to. And once this has iterated over the whole world, it will have all boundaries and their connected patches. That's the goal, at least. So after that, I have everything for the pathing algorithm. And that starts with resetting the path. And then picking a random goal that we've collected. From the list. It gets the patch at that goal position and puts it as the first member of the path, the first link. And then forever, until it's done, it's collecting the bounds of the patch. We've collected all the bounds in the world, and this collects the one around this specific patch. And it does that by going through all the bounds in the world. Yeah, if the return array is full, then break. Otherwise, if the patch occurs in the boundaries patches list, then add the boundary to the return array. So this will fill the NB array and return the size or the count. And we now have a patch and all its exits. And then we choose one, which one to follow. This function, which returns the next patch by taking all the exits and the current patch. So how it does that is it shuffles the neighbors. So I want to pick randomly from the exits instead of creating an array and using a random integer to pick from them. I just shuffle the array, of exits, and this should just work. This is an old function, I copied that over. And after the shuffling, it goes through all of them and path index. Oh, this is wrong, of course. That should be in path, so that's great. Let me see. Yeah. So for each exit, if the patches adjacent to that exit are both already in the path, then skip that one, because that would mean backtracking. One of the patches in the boundary will be in the path, because that's the one we're standing on. But the other one should not be. So I might assert here that one of them is in the path, but how do I do that? I mean, it's just the same. But with a or. So we find an exit that leads to a new patch. And then we return that new patch. Which is here just take the one slot that is not the current patch. And I return the actual patch for that. And I made this an integer, so I can actually just use the integers here as well. Might need one patch. Well, just let's leave it. Whatever. Can change that later. So now I've picked a new patch. If there's no new patch, then I break out of this. Otherwise I append the actually, is that the problem? Yeah, this patch is already added, the first one. So this should be the new patch. Okay. And that's it. That's the whole thing. I mean, I went through it and I didn't see, I saw 2 bugs, but none more. Okay, great. And the assertion kicks in. Where is it? Oh, it's the other display. So, okay, let's just make this If this is that and that is this, then continue. Actually, if they're both in the path, and if none are in the path, then as well. Come on. Where's the... oh, this is the assertion. Oh, okay. So that might also be bad. Okay, that's better. Let's see. Okay, there's no dangling paths. Don't let me speak too soon. I think there are no dangling paths. But it seems a bit short. 8, 6, 5, 4, 2, 1, 0. So this is the start. This is 1, 2, 3, 4, 5, 6, 7, 8, 9's down here. Wait a second. Okay, that would have collapsed. 9. That's just a huge... yeah, let's crop this off. Huge arm to this thing. Okay, then comes 10. This shouldn't be 10. And this patch should not be contiguous with down here. That's weird. This is looking much better. Path 10, path 11, 12, and then we go 13, 13, and then where do we go? Well, it crapped itself. Where's 14? Oh, I think that might actually be it. It stopped at 14. When it ran into itself. And I think that's because of this. Because of this, because it just stopped. It ran into itself and it stopped. This gives me hope. New hope downloaded. If it's less than, well, let's make this better. Find path. I mean, this should stop somewhere. This is path max. No. Yeah. Okay, let's buckle up and see what happens. This could actually be it. Okay, there's something here. Well, this certainly doesn't look like it. And that's even worse. Or did it fail after 1,000 tries? That could actually be it. Put message path. Okay, so well, that's not 100. Can tell you that much. And yeah, that's not. Okay, 0 here. But am I not resetting? What is this? There's no path 8. Am I not resetting something? Well, this is all just 8. And that's 7. Why does it jump all the way over here? And it completely flips out. I don't get it. Path 6, 5, 4, 2. Hmm. Yeah, I'm thinking wrong somewhere. Something does not add up, but it's pretty hard. I should add more visualization stuff, but I'm not sure what was that. Not sure what that would even be. I mean, at least it's in different places. Okay, 0, and this goes to 8. And then what happens over here? It's actually pretty clean. Zero, 0, 0, 1, 2, 3, 4. Yeah, no. Just had an idea, but it's a bad one. 4, 5, 6. And what is this? Also 5. Okay. 6. Still 6. Up until here. Okay. And then 7. I should maybe drop this down. Not like this. It's actually funny. I could. So this area here is walled off, right? I could add a secret here that's only available when this is depressed depressed to the ground by the pathing algorithm, like this. It's actually pretty funny. It sounds fun. I might do that. Okay, 6, 7 goes all the way over here. Might need to chop this off. Like this. Not sure. Okay, this is still 7, so that's bad. Not sure why it's... I said less than -1. Oh, it's... This doesn't... this is... because it's going -1 and then again -1 in height. It's never above -1. It just accumulates and then it walks down the elevation. So I need the original height. I have the tile, so that's good. Can flood, can flood. Well, I need it here. Oh, I have the tile here as well. That's great. So I have it, yeah. So can flood. Yeah, so I'm not interested in the elevation change. I'm interested in the total and the elevation difference. Like this. Where's the path? Oh, it's gone. No, it's gone. Oh, okay, it crashes. It's remarkable how much havoc this little code is wreaking. Okay, that's marginally better. Path 1. Path 0. Well, where's this? 3, 4, 5, 6. So something to do with the order. Pretty sure it's just one check somewhere that I'm messing up. Path, let's see. God. I was changing this, but I didn't finish it. Okay, path fail, that means... Okay, that means that. Let's bring it down to 20. Okay, it doesn't like... Why is this assertion springing? Assert NBNS is greater than 0. Well, I have no idea. And I'll have to take a break. Maybe it'll come to me then. But I'll be streaming tomorrow evening. I hope, if I'm not too tired. But yeah, thank you for watching, and I'll see you tomorrow. Have a nice evening.